So it says here velocity of Joe and Anna is v, and to travel a distance of 50 kilometers. So if Joe increases the velocity by a and Anna decreases her velocity by a, what is the difference in the time to travel 50 kilometers? Okay, so first of all, let's write the expression for v initial. This is for both Joe and Anna. So the velocity is equal to the distance divided by time. So d, distance is 50 kilometers, and the time is unknown. Okay, so we want to know what is the difference in time to travel 50 kilometers. Okay, so in this case here, we want to know, this is my time initial. We want to know the difference in the time for Anna and difference in time for Joe. So we need to rewrite this expression in terms of time. So time is equal to 50 over the initial velocity. Okay, so this is the time at the beginning for both of them, but one of them is going to slow down and one of them is going to speed up. Okay, so we're going to have an expression for time for Joe. So the time for Joe is going to be the distance traveled over the velocity. Okay, so his velocity is going to be the initial velocity plus a. We also need an expression for the time for Anna. So time for Anna is going to work out to be, well, she's traveling the same 50 kilometers and her velocity is now the initial velocity, and she's slowing down by a factor of a. So those are the expressions for time for Joe, time for Anna. Okay, so Anna's time is going to be greater because she's going slower. Joe's time is going to be smaller because he's going faster. So we want to find the difference in their time. So we want to find the change in time is going to be time for Anna minus time for Joe. And we'll write this as a rational expression. So it's going to be 50 over v initial minus a minus 50 over v initial plus a. Okay, so there's the expression. Since we know how to add and subtract rational expressions, we're going to get a common denominator here. Okay, so just to pause for a moment, a lot of this is about figuring out how to set up the relationship. So I started off with this velocity relationship. I had to rearrange it a bit because the question did involve time. Okay, it is asking for the difference in time, so then I needed to rearrange it to generate that expression. Once I've generated that expression, I can express the time for Joe and time for Anna, which is what I need to find the difference in terms of the information given of increasing the velocity, so I change the velocity, and decreasing the velocity, I change velocity. Okay, so moving ahead then, we need to find a common denominator and add. So the common denominator is going to be v plus a, v minus a. So I need here, this is going to need a v minus a. And here I need to times by v plus a and v plus a. So our expression is going to be 50v plus 50a minus 50v, and since it's a minus minus, we're going to end up adding the 50a. Okay, so the initial velocities cancel out, and I end up with v squared minus a squared. Okay, you can leave it in factored form if you like. The v initials cancel out, so I end up with 100a. Show that they cancel out, so we're going to cancel those out. So we're going to do 50 minus negative 50, which is plus 50. So it's going to be 100a over v initial squared minus the difference the increase and decrease squared.